Hello, my young friends. Today we concluded carbon compounds chapter. Now we are left with the last chapter of 10th class chemistry. Okay. Here, in this session, in the today's session, we are going to discuss how elements are classified. First is why we have to classify, because always classification makes work easy, to study easy. Therefore, if only few elements are there, countable are there, then no need to go for the classification. When the number is more, that time we feel what we require necessity of what classification. Okay, always you go to any shop or in your cupboard, we always classify the things. Okay, that makes work very easy and we can work comfortably. Okay, that's why the chemistry also, when the elements are becoming more and more in number year by year, so scientists felt what now we have to go for classification. So today we discuss how elements are classified. Okay, so once again I welcome you all for today's session on classification of elements. Life is full of chemistry. Okay, life is full of chemistry. See, lithium and iron is made as life. Okay, full of chemistry. And why it is full of chemistry? Because life is full of you people who are genius. Okay, so here I have taken germanium, nickel, uranium, sulfur, made it as genius. You're all genius elements of chemical world. Okay, so with this we will start today's session. Right? Okay. Now, many people tried to classify elements into different groups, but we go for those trials, those attempts which are very important. Okay, so among them, four important attempts or the classifications are: one is Davernier, the second one is Newland. All these are scientists. Okay, and the third one is Mendeleev, and the fourth one is by Mosley. What we are using the modern periodic table is it is the Mosley's what work. Okay, so let us start how they have started the classification of work from the beginning. So we go with what? First, Davernier's classification. Davernier, that time only few elements were known. Okay, so whatever elements were available during that time, whatever known elements were there during his time, so he made one law. That law is called as what? Law of triads. Tri means what? Three. So he made a set of what? Three elements in such a way that if you add atomic uh, mass of the first and the last and by 2 average, it is very close to the third one. So in that way, this is done by a lot of research work. Okay, so that means for his classification, what was the base? Base was atomic weight. See, for any classification, there is a base required. If I classify boys into different house, so I may be doing according to the entry of in semi school date wise, okay, or twice wise, okay, like that. So in the grocery shop, they do soaps one side. In the soap again, the company is one side. So some base is required for the classification. So here also in the chemistry to classify the elements, we require some base. So he has done on what base? He has done on the basis of what? Atomic mass, and atomic mass knowledge was known during that time. Okay, so taking the atomic mass as a base, he has classified known elements into triads. Okay, what is triad? Triad is set of three where the atomic mass of the middle one is equal to not nearly equal to the average of the first and the last. Okay, see, this is the triad: lithium, sodium, potassium one side, and calcium, strontium, barium on another set, and chlorine, bromine on another set. Okay, so let us see calculation part. See, so lithium, sodium, potassium, atomic mass. Okay, 7 plus 39 by 2 average, very close to the sodium. Same way, first one and the last one by 2 is equal to very close to the third one. Atomic mass of the first, atomic mass of the last, and by 2 is very close to the middle one. So very clever work done by Davernier. No doubt, wonderful work. But when the elements were discovered more and more, this law was not holding good. Okay, these are not the universal law. Maybe for some set of elements it was correct, but for some others it was not correct. Therefore, this law enjoyed for some years. Afterwards, it failed to explain this what classification. Therefore, uh, this law was this attempt was rejected. But no doubt, whatever contribution he has done, you have to respect the contribution. Science is dynamic, so it has to keep we have to keep moving into knowledge. So when this law was rejected, so we'll go to the other law. Okay, second attempt is done by Newland, and he gave his law. That law is called what? Law of octave. Oct stands for 8. What is 8? Why 8 is here? So during that time, he was having nearly some 20 to 30 elements, more than what Doberan is having. Okay, so therefore, so he was knowing the atomic mass of all those elements known during his time. So what he made, he arranged the known elements of that time in the increasing order of atomic weight in such a way that eighth one was having the repetition of the first one in the properties. Okay, that's why he has kept the name law of octave, oct for 8. Eighth element was having the similar property of the first one. That means the property was repeating when he was arranging in the increasing order of what? Atomic mass. Please here: hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and sodium. Now let's start from lithium. Lithium is the this starting point. So this is 1, 2, 3, 4, 5, 6. Okay, seventh, and this is the eighth one, which is having the same property of the lithium. Okay, now this is sodium is 1, 1, 2, 3, 4, 5, 6, 7, eighth. Eighth is potassium. Eighth element is the what it is having the same property like sodium. So this is why this is called what? Law of octave. Excellent, better than Governier, but this also enjoyed for some years and could not explain properly all the what observations of that time. Therefore, after some years, this law also was rejected. Now we'll go for the third attempt. Okay, which is done by the very eminent scientist, very intelligent scientist from Russia. He is known as Mendeleev. Okay, Mendeleev. So he is the one who gave a very excellent what idea for classification, and he is called as what? Author of classification of elements. Okay, so he was guided by two factors. Factor number one, increase in the atomic mass as usual, what earlier scientists took. But second what? Second was chemical properties are taken care. Earlier, only atomic mass was the base. But in this classification, not only atomic mass, second factor was increase, not increase, similar chemical properties are taken care. So during his time, approximately 63 elements were known. So he made 63 cards. He wrote all the elements' name on the top, and he wrote all the properties and the atomic mass. So he did a lot of research work on this. Then he concluded and he made this table. This is called Mendeleev's periodic table. And why this is so special? Because he is the one who said that if you arrange in the increasing order of atomic mass, keeping in mind the chemical properties, what horizontally and from top to bottom. Okay, so properties are repeating after a definite time interval. Okay, so because of this, he made into columns and the verticals. So when you arrange elements in the what horizontal way, okay, what this is called horizontal way, row wise, this is called period. He gave the word what? Period. So if you arrange in this way, this is called second period, first period, third period. But when you arrange from top to bottom in the same increasing order of atomic mass, carbon, silicon, germanium, tin. So this element is called what? Group arrangement. So okay. So arranging elements in the row wise is a period. Arranging elements in the column wise is called top to bottom is called what? Group. Okay, that means the two words period and the group coined by Mendeleev only. So Mendeleev was very clever. Not only he was very clever in making the two important words, group and the period, he also guessed that in future there are some elements which are going to discover. For them, already place was given in his table only. So he left some gaps. Why he left some gaps? So he was speculating that after some years, some elements are discovered. Those properties are similar to the above element. Therefore, below that element, you can place whatever new element is discovered. They are exactly same. This proved correct after the germanium discovery, after the gallium discovery. Means Mendeleev was so clever. So that's why till today his statue is there in one of the museums of in Russia. Okay, right. Okay. Now we'll go for what is the importance of this Mendeleev's table. Okay, already period and the group you understood. Some more important features are there. Some gaps were left for the undiscovered elements like gallium, scandium, and the germanium I told, and predict properties of elements on the basis of their positions in the periodic table. So by seeing the place, you can predict the property. For example, if I want to know the property of potassium, please see the place. So it is a potassium. Potassium is below sodium. So when it is below sodium, that means it is similar to sodium. So till today, potassium and the sodium are exactly similar. Though we explain in terms of electrons in the modern way, but that time, though he was not having the electronic idea, so by knowing the place only, he could explain the chemical properties. And third important achievement of Mendeleev was what? Accommodate noble gases when they were discovered without disturbing the original arrangement. That means during that time noble gases were not discovered. But what he said, in future there are some gases which are chemically least reactive. They will come. They are discovered. They will be invented. For them, a place is here only. He has earmarked the place for the noble gases. That means he was so clever that these will be having property of this kind. Place will be here only. So this is really rare to think. So that's why we have to salute the Mendeleev for his excellent achievement. Okay, right. Now, though he has done wonderful work, but some minor problems are there. They are called as limitations. So the main limitation is what? Hydrogen place was not fully justified because hydrogen is a double role element. Sometimes it behaves like a halogen, like a chlorine, bromine, iodine. Sometimes it behaves like a alkali metals, extreme left side. So where to place? So he was not in a position to place exactly hydrogen. So that was the confusion. So he left as it is. Uh, Today, where is the place we discuss later. Second was what? The discovery of isotopes. Already we learned in the 9th class, isotopes are what? Species of the same element having same atomic number, different atomic mass. When they have different atomic mass, then a different place has to be given. But they are chemically same. And how to give different place for the same element? That was a problem. So he was not having idea of atomic number. No, that's why that's a problem. Therefore, certain limitations are there. One more limitation is there. If you clearly go through the Mendeleev's table, what he said, he has earned the atomic mass in the increasing order of atomic mass. But in one or two cases where we find decrease in the atomic mass, only one or two cases, okay, but still are there. So these are the minor problems or the limitations or the anomalies. So let us rectify all these and we'll go for the better table what we are enjoying today. This is called modern periodic table, and they give a law that is called as a modern periodic law. What the law says? Law says the properties of the elements are a periodic function of their atomic number. Earlier, Mendeleev said what? The properties of the elements are a periodic function of their atomic mass. What is periodic function? Periodic function is what? After every interval of time, property repeats. This is called periodic function or periodicity. Okay, if you arrange in the increasing order of atomic mass, after certain time interval, property repeats. This is called recurrence of properties, repetition of properties, or periodicity, or periodic function. Okay, but now today we are arranging not on the basis of atomic mass. We have taken the atomic number. Why? Because when the J.J. Thomson discovered that atom is divisible, that time we felt the importance of electron. So because electron is the most important particle of an atom, so electron gives the atomic number idea. Therefore, we are using atomic number is a base for modern periodic table. Therefore, he has changed the law. Only one word, one phrase. In place of atomic mass, he added atomic number. So I will repeat once again the important law. the properties of the elements are a periodic function of their atomic numbers. When you arrange elements in the increasing order of atomic numbers, left to right or top to bottom, property repeats. Okay, right. This is the modern periodic table. Okay, so here also we have groups. What is a group? Group is the arrangement of elements in the increasing order of atomic number from top to bottom. So group number 1, group number 2, 3, 4, totally we have 18 groups here. Okay. Now what is the period? Period is the arrangement of elements in the increasing order of atomic number from left to right. Okay, that is called a period. So left to right, hydrogen, helium in first period, lithium to neon in the second period, sodium to argon in the third period, and so on. All these are periods left to right. Okay, so totally we have how many periods? 1, 2, 3, 4, 5, 6, 7 periods are there. How many groups? 18 groups are there. Okay, and these bottom members are there, no? These bottom members are actual places here only. Why they are brought at the bottom? We'll learn in the higher class timing. These are placed at the bottom of the periodic table to see the aesthetic sense, beauty of the modern periodic table. Okay, right. Now let us study what is there in the modern periodic table. Some trends are there. Okay, so what is trend here? Now, if you this side you see, no, this is the modern periodic table. Okay, so there are many trends. Out of many trends, we discuss only two trends. Okay. Trend one is what? Valency. What is valency? In the 9th class, we learnt valency is the combining capacity of an element. How it is calculated? It is calculated on the basis of what? Electronic configuration. Okay. So it is the number of electrons donates or accepts or shares. Okay. So accordingly, we calculate the valency. Now, see, when you see the modern periodic table, if you move from left to right, valency what happens? Valency increases by 1. Hydrogen 1, helium 2. In the second period, you see lithium 1. Okay, then beryllium 2, aluminum 3. So like that. So if you move from left to right, trend is what? Valency increases by 1. For the same valency, if you go from top to bottom in a group, what happens? Lithium, sodium, potassium. Lithium valency 1 only. Sodium valency 1. Because what is lithium? It is 2, 1. Sodium 281. Potassium 2881. Last shell contains only one electron. Only one is lost. Okay. So they have similar electronic configuration. So valency is calculated on the basis of what? Electronic configuration. So because they have the similar electronic configuration, because they have the same number of valence electrons, outermost electrons in the structure, so their valence is same. That means in the group valency is the same, whereas in the period valency differs. But what about the atomic radius? What is atomic radius? Atomic radius is it is the size from the center of the nucleus to the last electron. That is called atomic radius. So when you move from left to right, what happens? Atomic radius either same or slight decrease is there. Why decrease is there? See, when you move from left to right in the modern periodic table, electron is entering the same shell. For example, lithium 2 1, beryllium 2 2, aluminum, for example, sorry, sodium how much? 281, and magnesium 282, aluminum 283. So atomic number increases by 1 when you move from left to right. So that means the increase in the electron number is only by 1. That 1 electron, where it is going? It is going in the same shell. So when the electron goes in the same shell, at the same time, in the nucleus also proton is increasing. When the proton is increasing, nuclear charge is increasing. When the nuclear charge is increasing, it will control the outer electrons. So it will pull outer electrons because nucleus is very heavy, no? So because of the pulling of electrons by the nucleus over the outer electrons, the size slightly decreases. Whereas in the period you see sodium 281, potassium 2881. That electron goes far away. In the sodium, one electron is in the third shell, KLM. Whereas in the potassium, the only one electron is there, the KLM N shell, which is very far away. So, in the group from top to bottom, valency, what it is same, but atomic radius what becomes more. So, top to bottom, atomic size increases, whereas from left right, atomic size either same or decreases. So, this is a trend we have seen on the modern periodic table. Okay, so please go through this trend. So, okay, my dear boys, I think we have done the syllabus of 10th class. So, thank you for being with me in this journey of chemistry for the 10th class. Okay, so though the situation not supportive, but still we enjoyed class. I welcome any doubt regarding the chapters of chemistry. So, I wish you all the best for your forthcoming examination, right? And keep working. Thank you, my dear boys.